Welcome to Area and Perimeter Podcast. I think this is probably podcast 4. This was the material learned in class on that date right there, 10/10, October 10th. So distance formula, this is a little review, this part. So distance, remember, is just the difference in the x coordinates and the difference in the y coordinates. But distance has to be a positive number, so we square. And because we squared, we have to undo the squaring. So we have to take the square root. And so that's kind of review. But what's new here is the midpoint formula. I'd like you to put this in your notes. You can either put this on page 1, or you can put this on the back. There's lots of room there. All right, so you're going to write down this, You're going to write down this question there. Find the midpoint of 4, 3, and 7, 9. You're going to write down the formula there, which is we're going to take the average of the x coordinates and the average of the y coordinates. Right? So write down that formula with the red asterisk there. Right? And so now we're going to find the midpoint of 4, 3, and 7, 9. And very, very easy. Right? To find that midpoint, all we have to do is add the x coordinates, 4 plus 7, and divide by 2. That's our x coordinate of our midpoint, and add the y coordinates and divide by 2. We're just taking the average. All right? So 4 plus 7 is 11, and we can leave that just like that. And then 3 plus 9 is 12, and that we should simplify. So here our midpoint was 11 halves is the x coordinate, and the y coordinate is 6. All right, so just put that into your notes so that when we get to midpoint, you'll know how to find it. We need it a little bit in this lesson, and we'll need it a lot more in some other lessons. Okay, but very, very simple. Right? Very simple. All right, so let's find some area and some perimeter. I want you to just follow along. The first one is not in your notes. All right, so perimeter on a coordinate grid, just a little introduction here. If each box is worth 1, if your scale is 1, and you've got horizontal and vertical lines, you can count. So I've already put the values here. A and C are the same length. They're both 6. And B and D are the same length. They're both 4. When we're finding the perimeter of a rectangle, since we have 2 measures that are exactly the same, we can multiply the length by 2. In this case, the length is 6. And multiply the width by 2. In this case, the width is 4. That means our perimeter is 12 plus 8, or 20 units. Right? So we use linear measures, and if there's no unit of measure given, you can just put units. Okay? Now here, this one's a little hard to count, even though we have horizontal and vertical lines, because it's really hard to see the scale. There's no real coordinate plane here. It's hard to count that. So we're going to use the distance formula. We could also use subtraction, and I'll do that on some other problems, but I thought it would be a good idea to review some distance formula. Right, so to find A, using the distance formula, right, we take the difference in the x coordinates. So I'm going to use 4, 2 and 13, 2. Right, so I'm going to have 4 minus 13 squared plus 2 minus 2 squared. Doesn't matter who's first, just be consistent for x and y. All right, so 4 minus 13 is 9 squared. 2 minus 2 is 0 squared. Well, 0 squared is still 0. So this is going to be the square root of 9 squared, which is the square root of 81, or 9. Let's do the same thing with B. All right, so I'm still going to use that 4, 2, but this time I'm going to use, I guess I can call that x1, y1 again, but I'm going to use those values, 4, 10 and the 4, 2. Right? All right, so take the difference in the x coordinates. So I've got 4 minus 4 squared plus the difference in the y coordinates, 10 minus 2 squared, which is going to give us 0 squared plus 8 squared. Well, 0 squared is 0. So this is going to be the square root of 8 squared, which is the square root of 64, which is 8. All right, so we have A, we have B, we need C. All right, C is the one we really have to use the distance formula for. because it's not horizontal or vertical. And we're going to be using 4, 10, and 13, 2. So we have 4 minus 13 squared plus 10 minus 2 squared, which is 4 minus 13 is negative 9. Now we need those parentheses because we are squaring the negative. 10 minus 2 is 8. All right, so that's going to give us 81 plus 64, which is the square root of 145. All right, well, does that simplify? All right, so one factor of 145 is 5. 5 divides into 14 twice. 4 left over, remainder of 4. And 5 goes into 45 9 times. Well, those are not like terms, and matter of fact, they're both prime numbers. So you can't simplify the square root of 145. So for our perimeter, we're just going to add our 3 sides, A plus B plus C. That means our perimeter here is 9 plus 8 plus the square root of 145. We can combine the 9 and 8, and we should. 17 plus. And feel free to give the exact answer and just leave it like that. 17 plus the square root of 145 units. If you absolutely feel you must get a decimal approximation, I guess you can, but really just simplify. Keep your radicals as radicals and just simplify them if possible. Right? That way we have the exact answer. So this is exactly 17 plus the square root of 145. Okay. Let's look at the same problems, but this time area. I left the values up there because we've already figured out the measurements. All right, so area is measured in square units. Your base and your height have to be perpendicular. Here in the rectangle, that's no problem. We have 6, which is a horizontal line, and meets 4, which is a vertical line. And horizontal and vertical lines are perpendicular to one another. So to find the area, we simply have to multiply 6 times 4, which is 24. Actually, I think I'm going to put it up here in the box because there's plenty of room. So our area here is 24 units squared. Now the nice thing about number 2 here is it's a right triangle, right? And so on a right triangle only, your base and height will be sides of the triangle. Notice that A and B there are perpendicular to one another. We have a horizontal line and a vertical line, and those are always perpendicular. We can get 2 triangles in the same space as one rectangle, right? We can divide the rectangle in half. We have 2 triangles. So therefore, the area is half the base times the height. And so that will be 1/2 times 9 times 8. The order you multiply in doesn't matter. I can do half of 8, which is 4, and 4 times 9 is 36. Or you can multiply 9 times 8, which is 72, and half of 72 is 36. Either way, this area is 36 units squared. Right? That one wasn't too difficult. Let's do a couple more. All right, so we want to find the perimeter of these figures. Right? I'm only going to use a distance formula if I have a diagonal line. Otherwise, we're going to use subtraction, and we'll just take the absolute value to make sure it's always positive. All right, so this one here is my length and my width, or base and height. And so to find this measurement here, the length, I shouldn't point, you can't see me pointing. I would just take the absolute value of the difference between our 2 coordinates here. Notice that the y values aren't changing at all, right? So it's just the difference in the x values. So the absolute value of 2 minus 8, that would be the absolute value of -8, which is 8. So one side there is 8. And then the other side, it would be the absolute value of 10 minus 3, which is going to be 7. All right? So those are our 2 dimensions there. We've got, I'm trying to put this somewhere where it's not blocking. I guess I'll just put it right, I'll put it right here. All right, so we have our perimeter is going to be 2 times 7. Excuse me, 2. I'll just be consistent how I have it written on the board here. Not that it changes the value at all. But since I put L, 8 next to L, 2 times 8 plus 2 times 7. That means our perimeter is 16 plus 14, which is 30 units. All right, let's look at the next one. Now, we can figure out A and B without using the distance formula. It would just be the absolute value of the difference between 2 and 13. That's the absolute value of 11, or 11. B here is the absolute value of the difference between 12 and 4, right, because the x's aren't changing, which would be 8. And then C, we're going to have to use the distance formula. But my microphone needs to stretch more. That's probably because I have 2 knots in my microphone. There, I just got rid of one of them. Oops, no, almost. Aha, there, I got rid of one of them so I can move a little bit. All right, so to find the length of C, we have 2 minus 13. Ooh, that just looks terrible. And actually, I think I'll take 13 minus 2 squared plus 12 minus 4 squared, which is 11 squared plus 8 squared, which is the square root of 121 plus 64, which is the square root of 185. Does that simplify? Well, let's see. All right, so 185 is divisible by 5. All right, so 5 divides into 18 3 times, remainder of 3. 5 divides into 35 7 times, and both are prime numbers. So that is not simplifiable. So our perimeter here is just going to be the sum of our 3 sides. 11 plus 8 plus the square root of 185, which would give us a perimeter of 19 plus the square root of 185 units. There we go. All right, let's come down to our triangle here. And A is the only side that I don't have to use the distance formula for. It's just the absolute value of the difference between 1 and 5, which is 4. And let's use the distance formula for B and C. All right, so B here is going to be the square root of 7 minus 5 squared plus 7 minus 2 squared, which would be 7 minus 5 is 2 squared, 7 minus 2 plus 5 squared, which is 4 plus 25, which is the square root of 29. Well, that's a prime number, so I'm all done simplifying that. All right, let's do the same thing, but for C. All right, so we have the square root of 7 minus 1 squared plus the square root of 7 minus 2 squared, which gives us 6 squared plus 5 squared, which is, I guess I'll just keep going downward, 36 plus 25, which, that looks like 28. Let's fix that 5 there, which is the square root of 61. Okay, also a prime number. So not very exciting in terms of simplifying, and not a very exciting perimeter, quite honestly, because we don't have anything we can combine. We have 4 plus the square root of 29 plus the square root of 61. You can't add those together because they're not the same radicand. If they were the same radicand, so if I had like the square root of 29 and 2 square roots of 29, well, that would be 3 square roots of 29. But 29 and 61 aren't the same, so they can't combine them. Let's look at the last one here, and I think this one's probably one of the easiest ones here. All right, so the length of this side here is the absolute value of the difference between 4 and 9, which is 5. And the other dimension, I'm going to write it over here. The absolute value of the difference between 7 and a negative 3. And if you say 4, you're wrong. It'd be 10, right? 10 is that length. So our perimeter here is just going to be 2 times 5 plus 2 times 10, which is 10 plus 20, or 30 units. Pretty easy, right? Not too bad. Let's do the same thing, but area. All right, so I've left the measurements here because they're same figures. We just calculated them out. All right, the first one is a rectangle, super duper easy. All right, it's just going to be the base times the height, 8 times 7, the two perpendicular measurements, right? This is a right angle there. Those are perpendicular. So our area here is 56 units squared. Next to it, we have a right triangle. So, and for a right triangle only, the base and height are the legs of the triangle, because those legs are perpendicular to one another. Right, so our area is just going to be 1/2 times 11 times 8. Half of 8 is 4, and 4 times 11 is 44 units squared. All right, let's do the other easy one, which is the rectangle right below it. All right, again, the base and height are perpendicular to one another. So our area is just going to be 5 times 10, or 50 units squared. All right, let's get to the more complicated one. All right, so this is not a right triangle, and so therefore our base has to be perpendicular to the height. So when you don't have a right, so sometimes the height is not a side of the right of a triangle. And so here, always our height is the vertical distance from the base to the opposite vertex. Right, that straight vertical distance. And if that, sometimes it's a side, like for the rectangle and the right triangle, and sometimes it's not for a scalene triangle here. Right, so our base is marked A there, and that is from 1 to 5, that's 4. Here, our height, just put right here, our height is this vertical distance from 7.2 to 7.7, so our height is 5. Okay, which means the area of our triangle is 1/2, of course 1/2 base times height, so that's going to be 1/2 4 times 5. 4 times 5 is 20, and 1/2 of that is 10. So our area is, just squeezing it in here, 10 units squared. Okay. Well, you've watched me do quite a few problems, and now I have some for you. Okay. I have 3 that are in your notes, now that I've gone through these ones. Our first one is a triangle on the coordinate plane, and we're going to find the perimeter. Right. We're going to just use absolute value and subtraction to find, this is side A, this is side B. So to find A and B, since they're horizontal and vertical lines, we can just subtract the coordinates, and then we'll use the distance formula for C because it's diagonal. So A here is just the difference in the x coordinates. So -2, the absolute value of -2 minus 3, that's 5. The B here is the absolute value of the difference in the y coordinates. So 3 minus a -3, which is 6. Right, so we know A, we know B, and now for C, we're going to use the distance formula. All right, so it's the difference in the x coordinates, -2 minus 3 squared plus difference in the y coordinates, 3 minus a -3 squared. So -2 minus 3 is -5. Those parentheses are important because the negative is squared. And then 3 minus a -3 is +6. That's going to give us 25 plus 36, which is the square root of 61. That is prime number. So our perimeter, remember we just add up the sides, A plus B plus C here. So our perimeter is 5 plus 6 plus the square root of 61, which means our perimeter is 11 plus the square root of 61 units. All right, so put that one in your notes. It is at the bottom of the first page. All right. If you need more time, then just pause the tape. All right, and then area. I think I forgot to do this in the other class. Now that I think about it, right, we want to find the area here. So this is a right triangle. Right? So our area are going to be the legs. We're going to use the legs of the triangle to find the area. All right, so add what I just wrote into your notes, and let's find the area. So it's going to be 1/2. The legs of our triangle are 5 and 6. Actually, I probably should write the formula. 1/2 base times height. And that would be half of 30 or 15 units squared. And actually, if your third period did it, I think fifth period, I didn't do that problem. They have to make up a problem. All right, so we got 2 more we're going to do. All right, it won't take us too long. Right? And again, if you have questions on these, just ask me in class. Here's our next one. In your notes, I'd like you, so this is on page 2, I'd like you to write down what's listed there. So the height of a triangle is the vertical distance from the base to the opposite vertex. Okay, so base is perpendicular to height. All right, so we're going to just find the area here. So this is not a very long problem. We can subtract the coordinates, the x-coordinates, to find the base here. It's a horizontal line. So it's the absolute value of the difference between -4 and 4. And that would be the absolute value of -8 or 8. Our height here, notice it goes from this point here, looks like that's 1, 1, up to, no, it's not 1, 1, excuse me, it's -3. 1, -3. 1, -3. Or you can count, right? So 1, 2, 3, 4, 5, 6, right? So from -3 to +3, that's going to give us 6. So our height here is 6. All right, so that means our area is 1/2 base times height. Our area would be 1/2 6 times 8, and half of 6 is 3, and 3 times 8 is 24. Oh, actually, let me rewrite that because, same answer, but technically our base is 8 and the height is 6. All right, so still going to be 24 units squared. There we go. All right, and then one more problem, and we're only going to do half of this. Going to catch up to the rest of the class. So first of all, what are the increments for the x and y axes? All right, so notice here that I've got, if we look here, we have 1, 2, 3, 4. 4 spaces gives us 300. So each box, if I take that 300 for 4 spaces, divide 300 by 4, we get 75. So each box is worth 75. Right? So our scale is 75. We would not want to count boxes and say, for instance, the length of RS is 1, 2, 3, 4, 5, 6. It's not 6. Right? It's much more than 6. B, I'm just going to have you write it down. List some strategies you can use to determine perimeter and area of rectangle RSTU. We need to know the sides. So either use the distance formula to find the sides, or second, count the boxes and multiply by the scale, the value of each box. Right? That is okay. Right? But you have to take the scale into consideration. And we're going to do C. We're going to determine the coordinates of the vertices of the rectangle. And then tomorrow in class we'll calculate the perimeter and area. All right, so R here. Right, so if I look, I'm 1, 2 of 3 boxes. Right, so if I take 3 times 75, that means the x coordinate for R is going to be 225. If you notice that the y value is just one more box than 300. So the y value, I can either do it as 4 times 75, or I can just add 75 to 300. Either way, it's going to be 375. So R here is located at 225, 375. S here is on the same y value but different x value. I'm one more box than 600. Right, so I can either say I'm 1, 2, 3, 4, 5, 6, 7, 8, 9 times 75, or I can say I'm 75 plus 600. Either way, it's going to be 675 for the x. Still 375 for the y. For u, right, my x coordinate is going to be the same as r. It's going to be 225. My y coordinate is pretty easy to see. It's 600. And then t is going to be the same x coordinate, 675, and the same y coordinate as u there, 600. All right? So I'm stopping there. I have one more thing for you, and that is the closing. I would like you to do the closing. And the closing is right here. Oop, come on. There we go. All right, so I have two questions for you. Really easy. Number one, tell me two differences between perimeter and area. You can talk about units of measure. You can talk about how they're calculated, what they're measuring. All right, there's lots of things you can say. And number two, explain what the altitude or height of a figure is. And hint, you wrote it down in your notes. Right? And if you're not sure, go back and watch this tape and you can figure that out. Okay, so I will check that. That's your closing, and that's the end of my podcast. Have a great day. Bye.